वीडियो को देखना एंड प्रीवियस ईयर क्वेश्चन को अटेंड करना। इस सेशन को आप लोग दोस्त को शेयर कर दीजिए एंड जल्दी जल्दी ज्वाइन हो जाइए। और जो कोई भी नए हो इस चैनल पे सब्सक्राइब कर देना। ओके, और डेली प्रीवियस ईयर क्वेश्चन प्रैक्टिस के लिए चैनल के साथ जुड़िए। Previous year question is very important for any type of exams. So here in this video I discuss the fluid mechanics previous year question. I already completed 16 number class. Those are not watching the previous classes, please go through the playlist and you can see the previous classes. Okay, let's start. ज़्यादा ही बातें हो गए, फर्स्ट शुरू करते हैं। ठीक है, क्वेश्चन नंबर 401, आइडेंटिफाई द करेक्ट कंपैरिजन of the friction force for the body resting on a rough plane. It is given that it is inclined at the angle P from the horizontal. Suppose this is the horizontal and the angle with inclined angle is P and any body is rest. Okay, then forces act in this. This is mg sine p and this is mg cos p. This is friction force. Friction force for in rest condition, friction force of the body is more than the weight mg sine p. Okay, so A is the answer. Let's check the answer. When the body is rest condition, the friction on the body is greater than the mg sine p. Okay, the body is just beginning to move. Okay, friction on the body is equal to the mg sine p. When the body is sliding, then the friction force is less than the mg sine p. फ्रेंड्स, एक क्वेश्चन आप लोगों के लिए, काइनेटिक फ्रिक्शन एंड स्टैटिक फ्रिक्शन व्हिच इज ग्रेटर, दोनों का अंदर कौन ज़्यादा होता है when a body is moving? Next question. Center of pressure of submerged body equal to the distance of center of gravity of the body from free space. Vertical plane surface, horizontal plane surface, forward inclined surface, backward inclined surface. In scenarios is the center of pressure of a submerged body equal to the distance of the center of gravity when the force is on the plane is when plane is the horizontal surface. Okay, in case of horizontal plane surface which is the submerged in liquid, center of pressure equal to center of gravity. Next question, the vertical component of the hydrostatic force on a submerged curved surface. What is the vertical hydrostatic force of a submerged curved surface? Mass of liquid vertical above it, weight of liquid vertically above it, force on a vertical projection on the surface, product of the pressure at the centroid at the surface area. B is the answer, weight of the liquid vertical above it. Next question. For a submerged curved surface, the component of force due to static liquid is equal to. For submerged curved surface, the component of the force due to static liquid, weight of the liquid supported by the curved surface, force on a projection of the curved surface on the vertical plane, area of the curved surface, expressor, centroid of the submerged area, weight of the liquid supported by the curved surface. Here is the answer. For a submerged curved surface, the component of force due to static liquid is equal to the weight of the liquid supported by the curved surface up to the free surface of the liquid. The total force acting on a plane horizontal surface in the liquid is equal to space W is the specific weight of the water, X is the depth of the liquid, area of the surface. Total force equal to rho G A H bar. Here H bar is the X bar. Rho G यानी W X bar A is the answer. देख सकते हो explanation. Consider a plane surface of a arbitrary shape wholly submerged in the liquid due to the extension of the hydrostatic pressure of a fluid mass. A normal force is extracted on any part of a solid surface which is in the contact with a fluid. The individual force attributed over an area give the rise to a resultant force by given specific weight area into x bar. X bar is the depth of the liquid from the free surface. Next question is piece of metal of the specific gravity is given 7 and the floats a mercury of the specific gravity 13.6. What is the fraction of the its volume is under mercury? We know the specific gravity relative density gives us the friction of the volume is the under mercury. It is a short process. So if I compare those specific weight 7 by 13.6 and specific weight of the metal by the specific weight of the gravity, this fraction of volume is under the mercury. If you solve this, you can get the answer. Let's check the what is the answer is coming. Answer incoming 0.515. When the depth of immersion of a plane surface increase, the center of pressure will come closer to the centroid, move further away from the centroid, will be the same distance from centroid, depends on the specific weight of the liquid. A, come closer to the centroid. Next question is solid cylinder of the diameter 5 meter, height 5 meter, floating in a water with its axis vertical. Specific gravity of the cylinder material is 0.8. Which of the following statement is true about the cylinder? This is a cylinder which diameter is 5 meter, has the weight of the 5 meter, height is 5 meter, and diameter also 5 meter, submerged. Specific gravity of the cylinder 0.8. So we know the buoyancy force equal to volume of the water, rho G A देख लेते हैं, ठीक है। rho Vg of the rho Vg of the body of the water or the fluid. If you compare those, there is the x is coming, yani height is coming more. A vertical gate closed in the horizontal tunnel 4 meter in the wide drain running full with the water. The pressure at the bottom of the gate 196.2 kilonewton per meter square. What is the location of the center of pressure? Center of pressure, we know the center of pressure equal to Ig sine square theta, horizontal for the sine square theta equal to 1 Ig by A H bar plus H bar. How I calculate the H bar? We know the pressure P equal to rho pressure knowing hydrostatic force. The pressure equal to rho G H. From here we can calculate the hydrostatic pressure rho g a h bar. From here I can get the a. Okay, then here I put ig equal to for the 4 meter is given, so it is a square set, so bhq by 12, or you can calculate by the delete हो गया, area equal to 4 into 4, because the we assume that it is a square because only the wide is given 4 into 4, and so and the ig equal to 4 into 4 cube by 12. From here I we get the ig, then we can put the equation here, the solution you can see. Okay, हम लोग को डिस्टेंस पूछा है सेंटर ऑफ प्रेशर का डिस्टेंस फ्रॉम द सेंटर ऑफ ग्रेविटी. It is the IGH bar equal 2 by 27 meter. A tank of a water has gate in a vertical wall. The gate 4 meter height and the 3 meter wide. The top edges of the gate is 2 meter below the surface of the water. What is the hydrostatic force on the gate? Specific weight of the water is 10 kilonewton per meter cube. Okay, let's start. The vertical, the height of the gate is 4 meter, wide is 3, and from the free surface to 2 meter below, 2 meter below. So hydrostatic force equal to rho g a h bar. Rho g is given 10 into 10 to the power 3, area 4 into 3 into h bar, yani from distance from central from free surface 2 plus 2 4. Here you can multiply the 4 into 4, 16 into 3, so 638, last digit is coming 8. I think the D is the answer, 480 kilonewton. Let's check. Yes, if you solve the equation for 10 into 3 into 4 into 4, it's coming 480 kilonewton. Next question, the depth of the center of pressure for immersed surface inclined at the angle theta on the liquid surface lies in the distance equal dash the center of gravity. This is the Ig sin square theta by Ah bar below. A is the answer. Yeah, Ig sin square theta x bar plus x bar. Which components of the surface force is acting in case of the inviscid fluid? In a fluid only can resist the normal stress or the normal compress. This is the uh, normal component. Let's check the answer. Only normal components of a surface force is acting is case in viscid fluid. Real fluid has the zero shear stresses at the resist position, but ideal or the viscid fluid has zero shear stresses in the every position. A square plane, the surface 4 meter wide and the 4 meter depth. It is a square. Okay. Area 4 into 4 lies the vertical plane in water and its upper edge is horizontal and the coincide with the free surface. This type. Estimate the total pressure on the plane. So total pressure or hydrostatic force equal to rho g a h bar. Rho g is taken as g equal to 10 or 9.81. So g rho yani 1000 into 9.81 into area 4 square into h bar, this is 2. Half distance, half of the square is the center of the center of the square. If you solve, answer is coming 313,920 Newton. It's approximately 314 kilonewton. Next question. Identify the incorrect statement from the following options. The total hydrostatic force on a flat thin sheet immersed horizontally in water can be considered to passes through its center of the gravity, passes through a point that can be found by the taking first moment of the area about the x and y axis. mm, can be considered to pass through its center of the pressure. It's distributed along the edge. It distributed along the edge. Total hydrostatic force is the net force extracted by the fluid on the body. It is defined by rho g a h bar or x bar. Mm, In case of immersed horizontally flat thin sheet, center of pressure and the center of gravity of plate are at the same point. So total hydrostatic force can be considered to the passes through its center of the gravity and also can be considered to pass through its center of pressure. It is distributed same magnitude all over the surface. Independent of the orientation of flat surface, the point through which the hydrostatic pressure passes can be found by the taking the first moment of the area about the x and the y axis. Next question, friends. A 20-meter height dam is filled with the water up to top. The force acting on the vertical dam 20-meter high and the 25-meter wide is the given consideration. Density is 1000 kg per meter cube. Acceleration due to gravity g. Okay. Hydrostatic force equal to rho g a h bar. So rho is 1000 into g 9.81 taken as g, or 9.81 is g, into area 20 into 25 into h bar. H bar is height is 20, so h bar is half of height 10. After solving 5 into 10 5 uh, what is the after solving answer is coming uh, 1000 into g into 500 into 10 equal to 5g 10 towards 9 and 5g mega newton. The resultant pressure of liquid on the immersed surface will act as a point of center of gravity, lower edge of the surface, upper edge of the surface, none of these. A point of the center of gravity. Not, oh, sorry. The immersed pressure of the liquid immersed surface act as. This is the center of center of pressure. Pressure at center of pressure. Sorry, friends. This is not a center of pressure. जल्दबाजी में गलती हो गई. A point on a immersed surface through which the resultant force as a result of the fluid pressure act is the known as the center of the pressure. फ्रेंड्स वीडियो अच्छे लगे तो लाइक कर देना, ठीक है, और नए हैं तो चैनल को सब्सक्राइब कर देना डेली प्रैक्टिस करने के लिए. Next question, the center of pressure for a plane uniform vertical surface lies at a depth of half of the weight of the immersed portion, one third of the height of the immersed portion, two third of the height of the immersed portion. The center of pressure of plane uniformly vertical surface lies. Center of pressure. Horizontal or vertical surface equal to center of pressure equal to Ig sin square theta by a h bar plus h bar. If you put h bar equal to d by 2 or h by 2 bhq by 2 plane or bhq by 36, then it's coming, after solving it's coming 2 d by 3. So center of the pressure of a plane uniform vertical surface lies at the depth of the two-third of the length or the depth of the immersed portion. Okay, 2d by 3. Next question. A circular plate of 3 meter diameter is immersed vertically with its centroid and the depth of the 20 meter below water. Another similar plate in lying the horizontal at the depth 20 meter. The total force on the horizontal plane will be circular plate 3 meter dia immersed vertical. It's same because same on the force of the vertical plate. Because the hydrostatic force equal to rho g a h bar. Here angle is not considered. It does not depend on the angle. So inclined हो हॉरिजॉन्टल हो वर्टिकल हो हाइड्रोस्टैटिक फोर्स तो सेम ही आना है. Next question, the height of the free surface above any point is known as static head, intensity of pressure, both static head and the intensity of the pressure. It's called the both static head and the intensity of the pressure. Next question, in depth of the body immersed in some liquid from the free surface increases, then the total pressure force extracted by the liquid will increases because total pressure force equal to rho g a h bar. So हाइट इंक्रीज होगा तो प्रेशर भी इंक्रीज होगा, फोर्स भी इंक्रीज होगा और टोटल प्रेशर भी इंक्रीज होगा. Is directly proportional to h. Next question is circular opening of small dm diameter in the vertical side of the tank is closed by the disc of d-meter dia. Calculated the force on the disc if the head of the water above the horizontal diameter is 4 meter. Here the solution. So force same hydrostatic force equal to rho g h bar. Here h bar equal to free surface say 2 meter and half of the block is 2, so 4 is the distance of the centroid from free surface. And if you put the f equal to rho g a x bar area equal to pi by 4 d square, then it's coming the rho g pi d square. Okay. Next question, the water level in a dam is 10 meter. Total force acting on the vertical wall per meter length is total force acting on the vertical wall for per meter length. So कुछ नहीं ले पर मीटर लेंथ पे निकालना है, ठीक है. और द हाइड्रोस्टैटिक फोर्स इक्वल टू रो जी ए एच बार का इधर लेके आओ. देख लो. The length is coming. Okay, rho g a h, rho equal rho g l into h by 2. F by l equal to rho g h into h by 2. Force equal to, we know there are rho g a h bar. Okay, so area equal to length into height. Okay, or distance is from the centroid each h by 2. So this length divided by l, so f by l equal to, you can get the rho g h by 2. Okay, it's coming 490.5 kilonewton. Next question, which of the following statement are true with respect to the hydrostatic force on surface? Total pressure is force extracted by the static fluid on the surface, either the plane or curved. This force always act normal to the surface. In a vertical plane surface submerged in a liquid, the center of pressure lies the below of the center of gravity. The distance of the center of the pressure from the free surface is independent of the density of the liquids. The correct 1 and 2, 1, 2 and 3 is the correct. All is the correct. Next question, a vertical wall is subjected to pressure due to one kind of liquid on its sides. The total pressure of the wall per unit length. Same formula. P force equal to rho g a equal to a is the length into h by 2. So rho g h square by 2. Rho g h square by 2, c is the answer. Here rho g h square 2. A rectangle tank of the square section, cross section is square 2 into 2 meter and the height is 4 meter, is completely filled with the liquid. The ratio of the total hydrostatic force on the vertical wall to its bottom is 1, because pressure is same. Bottom वर्टिकल, सॉरी सॉरी सॉरी, नहीं कैलकुलेट करना पड़ेगा। देखो दोनों प्रेशर ही सेम, रोज ये एच बार, रोज ये एच बार, ठीक ही सोचा था, 1:1। थैंक यू फॉर वॉचिंग फ्रेंड्स। इफ दिस सेशन इज हेल्पफुल फॉर यू, प्लीज़ चैनल को सब्सक्राइब कर दो, और वीडियो अच्छा लगे तो वीडियो को लाइक कर देना। थैंक यू सो मच।